Okay, so this is a really fast tutorial about how to calculate biodiversity credits by hand. I don't recommend doing it by hand, and the main reason is because you're not going to optimize your site visits. There's a lot of overlap in space and time with this crediting method, and so it's better to use the code. But just so you guys know how the code is constructed. First off, I'm just going to do a quick overview of the project. So here's one of our projects. We use a group project methodology because we work with a lot of small farmers and they clump together to create this methodology, and I'll show you what it looks like. We're in Colombia, and here is an example of our site. And so as you see, there's lots of different plots on the site and with different land titles, etc. So what I'm going to do is, just for the purpose of this demonstration, I'm going to radically simplify what we show you. And we're just going to use like a large parcel in order to show you how the calculations work. So this is basically all the parcels, and we do a lot of work with mapping to make sure they don't overlap. But you don't have to worry about that for the purpose of most projects, which will be a large land plot. Okay, so that's the project. Now we're going to talk about the methodology. So most people know that with the methodology, you find an animal and you give a geocode. And then the animal's living range, which is a public data set, will tell you how big the animal's living range is. And that's going to determine the size of your crediting area. So for instance, the jaguar here has an 11-kilometer living range. So here's the jaguar observation, and this is the area that it covers. Whereas the giant anteater doesn't have as much of an area. And then here's a tapir. So I'll show you how that's done manually. So if I wanted to go in here, I'm in Google Earth Engine Pro. I'm going to add a circle, and I'm going to set the center of the circle at a geocode, and that's the geocode where I found the animal. And then I'm going to make the size of the circle the area of the living range. So let's say that my living range was 20 square miles, then I would set the circle like that. So my geocode is centered where I know the animal has been observed, and the area of the circle is, in this case, it's square miles. In most cases, it'll be square kilometers. So for instance, in this case, I have a radius of 4 kilometers. For a jaguar, the radius is 11 kilometers, but it really depends on the species. And you'll have to find that from your public data set based on the indicator species for your ecosystem. So I'm going to clear this and just use some predefined circles. So here's a circle for a jaguar. We're not going to use this one because it's so big. It's not always easy to understand how the plot is calculated. But we're probably going to stick with the giant anteater and the tapir. Now, in the methodology, not all animals are created equal. In other words, a tapir, although most indigenous groups will tell you that it is an indicator species, the public research doesn't entirely validate it, so we use half crediting for that. Whereas the giant anteater is not only an indicator species for indigenous groups, it also stands up in the public literature, and therefore it gets a 1 credit. And I'll go into a minute how to do that. That's called the integrity score in the methodology. Okay, so we talked about areas, we talked about observations. Now let's do some calculations. So we're going to do an area calculation for 2 different animals. So we're going to work with this land plot, which is a really large land plot in the tropical Andean biodiversity hotspot, and I'm going to go through a couple of observations. So let's say that you have your land plot first, and then you find your giant anteater. The giant anteater's home range only intersects your land plot for a little bit of it. And so the crediting area is going to be the overlap between where the animal's home range is. So this animal was observed in another part of our project, but it's the overlap between the animal's home range and your property. If you have a small plot of land, it'll generally cover the whole plot. But for a large plot of land, you might only get partial crediting for one part of the area. So that's a giant anteater, and as you can see, if you want to calculate this by hand, you would first put in your observation of the giant anteater, so there, and then you would create a shapefile and calculate the area of the shapefile of the polygon by zooming in here and creating a polygon and then estimating the size of the polygon. So here's the polygon. We've intersected where the land overlaps the observation, and then this gives you your area, and in this case, it's going to be 11,000 hectares. Oh, sorry, that's square yards. I was like, that's a lot. It's going to be 982 hectares for this one animal. Now, keep in mind, these observations don't last very long. They last for 60 days, and so this is really just 982 hectares, 982 credits for 60 days. Okay, so we're just going to do that really quickly for another animal. We're going to look at same plot. Let's say it's a different time, and you find a jaguar on your plot. So in this case, you've got your jaguar credit. Once again, we're going to zoom out a little bit. So here's your jaguar observation. Maybe you found it on a different part of your project. In this case, it's overlapping the plot, and you're going to go in there and you're going to make your circle with the 11-kilometer radius, which is what's the public data for a home range for a jaguar. So there's your circle, and that's the area of your plot it's crediting. And then you're going to go in there and give the area here, and you can do that manually by creating a polygon, and then you're going to do the area of the polygon. So that area is going to be 4,749 hectares. It's not common that you get to do that. Usually for us at least, you end up with a pretty small farmer's plots. You might get like 45 hectares, but it's kind of fun when you get a big plot. Okay, cool. So that's the crediting there. Let's talk a little bit about what happens when you get overlapping observations. So I'm going to go into overlapping area first, because that's the simple one. Believe it or not, it does get more complicated. Okay, so in this case, we have two observations, and they're overlapping each other. Let's look at what the observations are. Okay, one's an anteater. That's my brown circle, and one is a tapir. That's my green circle. And they both overlapped on the same plot, and the difference is that the tapir does not have an indicator score of 1. And so when you go to credit this area, you're not going to get the whole area credited at 1. What you're going to do is take the area that's covered by the animal that has the highest indicator score. In this case, it's going to be the anteater. So I'll show you what that looks like. So you're just going to get this area that's crediting. So that's the area that you get credited at a 1. And then where they overlap, you're going to get where just the tapir crediting during that time period, then you're going to get this area crediting at a 0.5. And so you're gonna basically subtract one from the other, and you're going to add the 2 credits. So in this case, you'll be getting measurements. You're going to get this area, which is, let me just see how much it is. It is 982 hectares crediting at 0.5, and you're going to get this area, which is, this is 982 hectares. That's like odd, but okay, that's what I'm getting, is 982 hectares at a 0.1. So if that makes any sense. So now let's talk about what happens when you overlap in time. So we talked about what happens when you overlap an area, and that's pretty simple, but when you're overlapping in time, that's when it gets a little bit nuts. So let's look at this here, and then you start overlapping an area in time, and then it gets really, really tough, which is why we like computer code. Okay, so let's talk about overlapping time. Okay, so we're just going to give you an example where there's 2 giant anteaters, and let's say that they had their little bit delay, like one is exactly 10 days earlier than the other one. So let's talk about how you calculate area during that time. So you've got your 2 observations, you picked your central point, it's created basically the 2 areas. So here's one of your circles, and this is the area that it credited. You can see it didn't credit the far corners because it didn't overlap of the land plot. And then here's the other one, and it's crediting this area, which is within the observation. Oops, sorry. Give me a second. So it's crediting this area, which is within the borders of the circle. And then there's a little bit of an area that's overlapping both. And if you put both of these up here, you can see how some of this area is being credited by both. So the best way to understand this is the following. So for the first, let's say that this is your first observation. So this area is going to credit for the first month, right? And then there's going to be a 10-day period where this area, it is not double crediting, but you're crediting a bigger area. So you're crediting not only this area and this observation, but also this area. And then there's going to be a 10-day period where you're only crediting this other area, and that means you're not going to be getting this corner, these corners here. You can't, because these are animals. The giant anteater is an animal with an indicator score of 1, so you're never going to get more than 1 for the time that the 2 observations overlap. However, like for 10 days in this 40-day period, you're not going to be crediting this area. And for 10 days in this 40-day period, you're not going to be crediting the other area, this other area over here, if that makes any sense. Obviously, it can get a little bit complicated when you start taking in multiple indicator species, multiple time periods, multiple and multiple overlapping areas, or when you add in multiple plots. And so that's why we recommend that you use the computer code, but it is possible to do this by hand. I can show you an example where we took a bunch of different crediting. Here is a very brief example where we had let me see how many observations. 1, 2, 3, 4, 5, 6 observations that covered multiple farms and that didn't overlap in time. So they were basically discrete circles, and then we went in and calculated each parcel, like how many hectares were in each parcel, and then how many hectares were covered by the observation. So this is an example of the kind of simplistic crediting you can do with observations that aren't overlapping in time. But when we start overlapping in time, it gets really complicated. One last thing, when we do our computer code, when we calculate in time, if you look at this diagram here, we actually slice each observation. They go 30 days before and 30 days after, so we actually slice each area into 1/60th. And then on a day-to-day basis, if the areas overlap, we do the calculation on a day-to-day, and then we re-add them. That's how we get it. And the nice thing about computer code is you can kind of do partial crediting. So you could just do one area for 1/60th, and then add that to one area for 1/60th, etc. And that makes it a lot easier to sum, and it makes the code simpler. So if you're doing it by hand, I suggest that you do it that way. You would have to split it up each day and then manually add it 1/60th at a time. I hope that's helpful.